Hello everyone, let's discuss the winding resistance and reactance of a transformer. So now we have introduced a winding resistance in primary winding as well as in secondary winding, right? So later we have to introduce the winding reactance and followed by winding reactance in secondary winding. Then only we have to discuss the exact equivalent circuit of transformer. So first I would like to discuss with a winding resistance. So the equivalent circuit of a transformer with a winding resistance is like this, right? We have a supply voltage and we had a discussion that operation of a transformer under load condition, and we all know that this current I1 is nothing but what? Should be equals to plus, right? So finally, because there is a load, there is a secondary current. So in this primary winding we have provided a primary resistance of R1 like that. In secondary winding a secondary resistance of R2, that is R1 is winding resistance of primary and R2 is what? Winding resistance of secondary. So in this case no load current is neglected. So what is happening if we neglect the no load current? What is the magnitude of no load current? I1 should be equals to I0 plus I1 dash, right? If I0 is neglected, what will happen? I1 should be equals to I1 dash only, right? I1 should be equals to I1 dash only. Why it is neglected? Since the magnitude of I0 is what? Very less. Since the magnitude of I0 is, since the magnitude of I0 is very less. What is the value? It is approximately equals to 5% of full load current, right? So that's why we have neglected I0 current here. Then what is happening? So because of the winding resistance, what is happening? Obviously whenever there is a resistance in any winding, because of that winding resistance obviously we have a voltage drop. So when we provide the supply voltage, the current through the branch is nothing but I1, right? So I1 into R1, which is nothing but IR drop. So this is happening. Obviously whenever there is a resistance in any winding, obviously we have a voltage drop, and obviously I square or losses are exist in the transformer winding. So those I square R losses are nothing but copper losses. So therefore the voltage equations, so from this primary loop and from this secondary loop, what is the voltage balance equation? So this is V1. Why it is negative sign? This corresponding self-induced EMF is opposes the supply voltage. That's why V1 should be equals to minus E1 plus the drop in the primary winding. So coming to secondary, E2, the mutual induced EMF should be equals to terminal voltage plus I2 R2. So by using KVL we can get this voltage balance equations from primary and secondary loops. So with respect to primary, from this what are the total losses? I1 square R1. From this secondary, I2 square R2. So this is the copper loss. Copper loss with respect to primary winding, right? This is the copper loss PCU with respect to secondary winding. Then the total copper loss is nothing but what? I1 square R1 plus I2 square R2. So the total copper loss in a transformer is what? I1 square R1 plus I2 square R2. So what is the effect of winding resistance? We have to get the copper losses due to winding resistance, we are going to get the copper losses in the transformer. So the condition must be satisfied while transferring winding resistance from one side to another side. Is copper loss is of that resistance should be maintained as constant, so that the performance of transformer should not be affected. So what is the total copper loss formula? I1 square R1 plus I2 square R2. Now I would like to change the secondary resistance, that is R2 should be changes from or transferred from secondary side to primary side, like that primary side resistance is transferred to secondary side, right? So primary side resistance should be transferred to secondary side, like that secondary side resistance should be transferred to primary side. So what is the need of transferring resistances from primary to secondary or secondary to primary? What is the need of transferring a resistance simple? What is the need? What is the need of transferring resistances between primary and secondary? What is the answer? Simple. This is the question. The answer is what? To make the calculations easy. Simple. So previously R1 is present in primary winding, R2 is present in secondary winding. So what is the condition here? Transfer resistance from secondary side to primary side. That is, there is no resistance in secondary side. There is no resistance in secondary side. That resistance should be transferred from secondary side to primary side. That's why this should be notated as R2 dash. That's why this should be notated as R2 dash. But at any case, while transferring, there is no change in the copper loss. That is the very important statement. But while transferring, there is no change in the copper losses. What is the need of transferring resistances from primary to secondary or secondary to primary? The reason is simple, to make the calculations easy. So for that, obviously there is no change in the copper loss. That is, previously R2 should be present in the secondary winding. What is the statement here? Transfer of resistance from secondary side to primary side. Therefore, we can write here one point. Copper loss before changing should be equals to copper loss after changing. So copper loss before changing is nothing but what? So before changing, what is the copper loss? I1 square R1 in primary winding. Sorry, I1 square into R2, right? Before changing, that is I1 square into R2. Copper loss after changing. After changing, what is the notation? R2 dash, that is secondary to primary. After changing, that is I2 square, sorry, I1 square. Current is what? I1 square into R2 dash. Why it is, sorry, this is I2. Previously the current, this is I1, this is what? I2. Previously there is a resistance, right? R2 here. Therefore before transferring I2 square into R2, clear, I2 square into R2. After changing, that resistance should be present in primary winding, because we have a transfer of a resistance from secondary to primary. Therefore, before transferring, what is the copper loss? Only I2 square R2. After transferring, the current in the branch is nothing but I1 only. That's why I1 square into, what is the resistance here? R2 dash. Clear? But at any case, there is no change in the copper loss. That is very most important point. Before changing or after changing, the value of copper loss should be same. Therefore, from this equation, R2 dash should be equals to R2 into I2 by I1 whole square. So we all know that what is the transformation ratio? What is the transformation ratio? K should be equals to I1 by I2, right? Or E2 by E1 or V2 by V1. Then substitute in place of I2 by I1, which is nothing but what? Since I2 by I1 is nothing but 1 by K. Then substitute in place of I2 by I1 with K. That's why R2 dash should be equals to R2 into 1 by K whole square. So the total resistance of a transformer with respect to primary side is what? That is R1 and R2 dash. The total resistance with respect to primary side is what? R1 and R2 dash. That's why R01 is nothing but what? This is the notation of a resistance with respect to primary. That is R01, which is equals to R1 plus R2 dash. This is the total resistance of a transformer with respect to primary. That is, with respect to primary means what? Transferring from secondary to primary side. Transferring of a resistance from secondary to primary. That's why with respect to primary we have to say the total resistance is what? R1 plus R2 dash. So this is the value of resistance, total resistance of a transformer with respect to primary side. So like that, transferring of a resistance from primary to secondary side. So previously we have a resistance right here. Now there is a transferring of a resistance like this. The current through this is nothing but I1 only. The current through this is nothing but I2 only. What is the condition? PCU before transferring should be equals to PCU after transferring. So what is the copper loss before transferring? Before transferring there is a branch, right? R1. I1 square into R1. That's why I1 square into R1. Clear? Copper loss after transferring, what is the notation here? R1 dash. That's why the current through this branch is nothing but what? I2 square into resistance is nothing but R1 dash. So from this, R1 dash should be equals to R into I1 by I2 whole square. We all know that. What is the value of I1 by I2? That is nothing but transformation ratio K. So therefore the total resistance of a transformer with respect to secondary, means what? Transferring of a resistance from primary to secondary. That is the meaning. Okay, with respect to secondary means what? Transferring of a resistance from primary to secondary. That is R2 plus, the total resistance is what? R2 plus R1 dash. R2 plus R1 dash. This is about the transferring of a resistance from primary to secondary or secondary to primary. But at any case, is there any change in the value of copper loss? Obviously there is no change in the copper loss. Then the total copper loss with respect to primary side is what? Which is equals to I1 square into R01, right? With respect to primary, I1 square into what is R01? R01 is what? See, R1 plus R2 dash. You can write R1 plus R2 dash. Like that, what is total copper loss with respect to second? I2 square into R2 plus R1 dash, right? See, R2 plus R1 dash. So like that, the total copper loss of a transformer, is nothing but what? There is no change in copper loss, right? That's why I1 square R1 plus I2 square R2. This is before transfer. This is what? These two are what? After transfer. At any case, before transferring value should be equals to after transferring value. Is there any change in the value of copper loss? No. So you can calculate the resistance or copper loss with respect to any of the side, whether with respect to primary side or with respect to secondary side. At any case, you are going to get the same amount of copper loss. Total copper losses. There is no change in the copper loss if you transfer a resistance from primary to secondary or secondary to primary. Okay. Then like that, similarly, in case of reactance also, we are going to get the reactances, transfer of a reactance from secondary to primary side. We have a what? X2 dash should be equals to X2 by K square. Like that, transferring of a reactance from primary to secondary is nothing but K square into X1. Same like resistance calculations. There is no change in the formulas, only we have to replace the term R with X. So the total leakage reactance with respect to primary side is nothing but what? Simple, X1 plus X2 by K square, same like in the case of resistance. Like that, the total leakage reactance with respect to secondary, referred to secondary. This is the total reactance referred to primary. This is the total reactance referred to secondary. Same, if you know the formulas for resistance calculation, just you have to replace the value of R with X. Then only you will get the formulas for reactance calculations. Now, this is the equivalent circuit with respect to resistance and reactance. Previously, what we have? Simple. We have this winding, coupling, and we have this winding. There is a load, right? But here I naught is neglected. That's why there is no branch here. But actually, what we have? We have a branch like this. This is the supply voltage V1, right? This is the equivalent circuit with R1 and X1 and R2 and X2. Remaining all are same. That's why with respect to this loop, what we have? This is the equation with respect to primary. This is the equation with respect to secondary, right? V1 equals to minus E1 plus I1 R1 plus this is reactive components J I1 X1. So from this we all know that R1 plus J X1 is nothing but what? I1 plus J1. Similarly, with respect to secondary loop, E2 should be equals to what? E2 V2 plus I2 into Z2. These two are very most important. So what is the need of transferring a resistance from primary to secondary? To make the calculations easy. For our convenience purpose only, we have to transfer the resistances. Obviously, there is no change in the copper loss before transferring and after transferring. The value should be same, but the value of copper loss should be changes with respect to load current. The value should be changes with respect to load current. Before transfer should be equals to after transfer. But PCU depends on load current I2. We will discuss in detail. PCU depends on load current. That is, if load changes, copper losses are also changes. This is very most important bit. That's why copper losses are called as variable losses. Okay. This is the total copper loss of a transformer with respect to resistance and reactance. Thank you.